Example, reduce the following equation to a canonical form and hence solve it. Uxx equals to minus 2 sin x uxy minus cos square x uyy minus cos of x uy equals to 0. Solution. The given differential equation is uxx minus 2 sin x uxy minus cos square x uyy minus cos of x uy equals to 0. Equation 1. Comparing equation 1 with the standard partial differential equation a uxx plus b uxy plus c uyy plus d ux plus e uy plus fu equals to g, we have a equals to 1, b equals to minus 2 sin x, c equals to minus cos square x, d equals to 0, e equals to minus cos x, f equals to 0 and g equals to 0. Now the discriminant b square minus 4ac equals to minus 2 sin x square, b's value minus 4, a is 1 and c's value is minus cos square x, so equals to 2 2s are 4 minus minus plus sin square x plus 4 minus minus plus 4 into cos square x. So taking 4 common, sin square x plus cos square x equals to 1. So 4 is greater than 0. Hence the partial differential equation is a hyperbolic. The characteristics equation are dy over dx equals to b minus square root of b square minus 4ac upon 2a equals to b's value is minus 2 sin x minus square root of 4 b square, b square's value 4 sin square x plus 4ac's value is minus minus plus 4 cos square x upon 2 equals to minus 2 sin x. 4 taking 4 common, 4 square root is 2 sin square x plus cos square x equals to 1. So 4 in the square root is 2, so taking this is minus 2 sin x minus 2 upon 2, taking 2 common, so minus 2 into sin x plus 1, 2 to 2 cancel out equals to minus sin x plus 1 equals to minus sin x minus 1. Equation 2. And dy over dx equals to b plus b square root of b square minus 4ac upon 2a equals to minus 2 sin x plus square root of 4 sin square x plus cos square x upon 2, so equals to minus 2 sin x, taking this value equals to 2, so taking 2 common, 2 to 2 cancel out, so equals to 1 minus sin x. So equation 3. Integrating 2 and 3, we get y equals to cos x minus x plus c1 and y equals to cos x plus c2. Thus we choose the characteristics lines as xi x plus y minus cos x equals to c1 and eta equals to minus x plus y minus cos x equals to c2. Now we have the desired transformation as xi equals to x plus y minus cos x, eta equals to minus x plus y cos x. So xi x equals to differentiation with respect to x 1 plus sin x, xi y equals to differentiation of y with respect to y equals to 1, rest of the term is 0. So xi xx equals to, again xi x differentiation with respect to x 1 is 0, sin x is cos x. So xi xy equals to xi x differentiation with respect to y, there is no term containing y, so equals to 0. Xi y is 1, so again equals to 0. Eta x equals to, now differentiation of eta with respect to x, 1 minus 1 plus sin x. Again differentiation of eta x with respect to x, first term is 0, sin x differentiation is cos x. So xi y eta y equals to differentiation of eta with respect to y, there is only one term containing with y with respect to y equals to 1. Again differentiation with respect to y, xi eta y equals to 0. Eta x y, now differentiation of eta x with respect to y, so there is no term containing y, so equals to 0. So that we have from the equations a bar equals to a xi x square plus b equals to xi x xi y plus c xi y square, b bar equals to 2a xi x eta x plus b into xi x eta y plus xi y eta x plus 2c into xi y eta y. C bar equals to a eta x square plus b into eta x eta y plus c into eta y square. D bar equals to a xi xx plus b into xi xy plus c into xi yy plus d into xi x plus e into xi y. E bar equals to a eta xx plus b into eta xy plus c into eta yy plus d into eta x plus e into eta y. F bar equals to f and g bar equals to g. We get a bar equals to a is 1 eta x square is 1 plus sin x square minus b equals to minus 2 sin x, xi x equals to 1 plus sin x, xi y equals to 1 minus c equals to minus cos square x, xi y square equals to 1 square, so equals to 1 plus sin square x plus 2 sin x minus 2 sin x minus plus minus 2 sin square x minus cos square x equals to 1 plus sin square x minus 2 plus 2 sin x minus 2 sin x cancel out. The next term is 2 sin square x minus cos square x, so 1 will cancel with this one, so equals to 1 minus sin square x minus cos square x, so equals to, taking minus common, 1 minus sin square x plus cos square x, so equals to 1, so 1 minus 1 equals to 0. B bar equals to 2 into a's value is 1, xi x equals to 1 plus sin x, eta x value is minus 1 plus sin x, minus b value is 2 sin x into xi x value 1 plus sin x, eta y's value is 1 plus xi y's value is 1, and eta x value is 1 minus 1 plus sin x plus 2 c's value is minus cos square x, xi y's value is 1 and xi eta x value is 1, so equals to 2 into 1 plus sin x minus 1 plus sin x minus 2 sin x, 1 plus sin x minus 1 plus sin x plus minus minus 2 cos square x, so 2 into minus 1 plus sin x minus sin x plus sin square x minus 2 sin x into 2 sin x minus cos square x, so equals to minus 2 plus sin x minus 2 sin x plus 2 sin square x minus 4 sin square x minus 2 cos square x minus 2, this term will cancel with this term, so 2 with less 2 sin square x will minus with 4 sin square x will remain minus 2 sin square x minus 2 cos square x, so equals to minus 2 into 2 minus 2 is taken common, so sin square x plus cos square x equals to 1, so equals to minus 4. Similarly, c bar equals to 1 into minus 1 plus sin x whole square minus 2 sin x minus 1 plus sin x into 1 minus cos square x into 1 square, so equals to 1 plus sin square x minus 2 sin x plus 2 sin x minus 2 sin square x minus cos square x, so equals to, these two term will cancel out, so we have remained with 1 minus sin square x plus cos square x equals to 1, so 1 minus 1 equals to 0. Similarly, d equals to 1 into cos x 2 sin x into 0 minus cos square x, d bar is value is cos square x plus 0 minus cos of x into 1 equals to cos of x minus 0 minus cos of x equals to 0. Similarly, e bar equals to 1 into cos of x minus 2 sin x into 0 minus cos square x into 0 plus 0 minus cos of x into 1, so equals to cos of x minus 0 minus cos of x to cos of x cancel out equals to 0. Similarly, f bar equals to 0 and g bar equals to 0. Now the putting the value of the a bar, b bar, c bar, d bar, e bar and f bar and g bar in a bar u xi plus b bar u xi eta plus c bar u eta plus d bar u xi plus e bar u eta plus f bar u equals to g bar, we get 0 minus u xi eta plus 0 plus 0 plus 0 plus 0 equals to 0, which implies minus 4 u xi eta equals to 0, which implies u xi eta equals to 0, equation 4, which is the required canonical equation to solve the equation 4. Integrating 4 with respect to the xi, we get u eta equals to f eta, equation 5, where f eta is a arbitrary function. Integrating 5 with respect to the eta, we get u equals to integral of f of eta d eta equal plus g xi or u equals to psi eta plus g xi, where g xi is another arbitrary function. Thus uxy equals to psi y minus x minus cos of x plus g y plus x minus cos of x, because eta equals to minus x plus y minus cos of x and xi equals to x plus y minus cos of x, hence the solution.